Okay, so we are moving into Unit 6, and today we're going to start looking at exponents and some of our exponent properties. So today, specifically, we're going to look at the first half of Unit 6.1, which is where we talk about a zero exponent, a negative exponent, and then multiplying with exponents. So this entire front page of your notes are kind of the general rules, so to speak. So we're going to kind of take them step by step, and then we'll look at one of the rules, and then we'll flip over to the next page to actually put it into place. Then we'll look at another rule, flip it back over, and put that rule into practice, okay? So first, let's look at the zero exponent. So zero exponents basically means like 4 to a 0 power, okay? Anything to a 0 power is always going to be 1. Okay, so for any non-zero number. Now, if we had 0 to the 0 power, we would say that that is undefined, but we won't see too much of that in what we do in Algebra 1. So, for example, 4 to the 0 power is 1. N to the 0 power is 1. If I had 763 to the 0 power, that would also be 1. If I had X, Y, Z all to the 0 power, that would actually be 1 as well. So anything to the 0 power is 1. So that's our first concept. The second concept we want to look at is a concept of negative exponents. So today we're going to talk about what we do with exponents. Later on, when we get into when we're dividing with our exponents, that's when we'll kind of talk about why these negative exponents are the way that they are and what we do with them. But we're just going to introduce them and work with them a little bit first. So whenever I have a negative exponent, I always want to move it. It is not mathematically let's say correct, but it's kind of like a math faux pas to leave a negative exponent in any type of expression. And so whenever we have a negative exponent, we move it. So if it is something like this, where it's in the top of a fraction, then we would just take the reciprocal and we would move it to the bottom. Okay, if it happened to be in the bottom, so let's say we ended up with something like this, 1 divided by 4 to the negative 2 power. Well, in that case, we would move that 4 to the second power up to the top. And so then it would just be 4 to the second. So if it's in the top, we move it to the bottom. If it's in the bottom, we move it to the top. So let's take a look at what some of that looks like. So looking at these first problems here, 2 to the negative 5 power. So 2 to the negative 5 power is the same as 1 divided by 2 to the 5th. We move it to the bottom, okay? So because there was nothing left there, we put a 1 as a placeholder, so we move it to the bottom. This is the same as 1 divided by 2 to the 5th. Well, 2 to the 5th is 2 times 2 times 2 times 2 times 2. 5 of them, correct? So that would end up being 1 divided by 32, because 2 times 2 times 2 times 2 times 2 is 32. Okay, looking at another one, number 2, 10 to the negative 3rd power. So that's 10 to the negative 3rd would be 1 divided by 10 to the 3rd. And then 1 divided by 10 to the 3rd, that's the same as 1 divided by 10 times 10 times 10, because 10 to the 3rd is 10 times 10 times 10. And that gives me 1 divided by 1,000. Okay. And then one more like that, 1 divided by 5 to the negative 4th. Well, that would be the same as 5 to the 4th power. When you move it up or down, you change that power to a positive, and so it's no longer a negative. That's why we do that. So 5 to the 4th power would be 5 times 5 times 5 times 5. 5 times 5 times 5 times 5 is 625. Okay. So let's take a look at number 4. Now, number 4, we've got 5y to the negative 4th power. Now, the only thing here that is raised to the negative 4th power is the y. The 5 is not. It would need to be in parentheses if you wanted the 5 to be raised to the negative 4th power. And don't worry, we will look at some of those eventually, but not just right in this particular part. So the only thing that needs to be moved is this portion right here, the y to the negative 4th. So when I do that, my 5 is going to remain in the numerator, or on top, and I bring the y to the negative 4th to the bottom, and when I do that, I make that exponent positive. So I end up with 5 divided by y to the 4th, and that's my final answer. Now in number 5, a to the negative 3rd power, well, a to the negative 3rd, I need to move that. I need to move a to the negative 3rd up to the top, so it's going to be up there with the 8. So we'll have 8a, and when I move that exponent, it becomes a positive. And that's it. That's the final answer. You could technically put that, over 1 if you wanted to, but you certainly don't need to, okay? On this next one, 9x to the third, y to the negative second. Well, the only thing that is raised to the negative power is this y value, or this y. Okay, so that's the only thing that has to be moved. So the 9x to the third remains where it is. It remains on top. And then the y to the negative 2, I need to bring that to the denominator. And when I do that, my exponent becomes positive. And that is my final answer there. Okay. Now on this next one, we've got x to the third divided by x to the negative 1 times y. Now the only thing that has a negative exponent is the x that's in the denominator there. So that portion needs to move up to the top. So we'll have x to the third, and then you've got your x to the first, which yes, that is the same as x. As if some of y'all are asking, x to the first is the same as just x. And then I've got that y still in my denominator. Now, in just a minute, we're going to learn how to simplify this, but we haven't looked at that property yet. So for now, I'm going to leave that just like that. Okay, same thing for number 8. If I look at number 8, this portion right here has my negative exponent, so I want to move that part to the top. So I'll have the a to the first and the b squared, and then that would leave me with b to the third in the denominator. Now the reason I put the a first before the b is because typically we do write our variables in alphabetical order, and so that's why I put the a first. And then the last one of these, number 9, x to the negative 4th. The only thing that is raised to the negative 4th power is the x. The 5 is not. And so the only thing that needs to be moved into my denominator is the x to the 4th. When I move it, that sign becomes, or that exponent becomes positive. And then in my numerator, I'm still going to have the 5 and the y squared. Okay, so let's flip it back over and let's take a look at one of our other rules. So next rule, product of powers and power of a power. So first, product of powers. This would be something like if I had 4 to the 6th times 4 to the 3rd. Well, 4 to the 6th, remember, would be 4 times 4 times 4 times 4 times 4 times 4. 6 of them. And then 4 to the 3rd would be 4 times 4 times 4. So if you think about this, I have 9 of those, right? This is 4 times 4 to 4, 9 times. And so that's the same as 4 to the 9th power, which is what we have right here. Notice to get the 9, you can simply add your exponents. And so that's what they did right here. 6 plus 3 is 9. This is why this works if you were to think about writing it all out. Okay, so anytime I have both of the bases there, I can simply add my exponents. That's a little bit different than if I have the power of a power. So for the power of a power, notice that this is 4 to the 6th raised to the 3rd power. Well, think about what this would look like. Something raised to the 3rd power means you multiply it 3 times by itself. Okay, so that would be 4 to the 6th times 4 to the 6th times 4 to the 6th. So now if you think about what that is, if you were to expand it even more, this would be 4 times 4 times 4 times 4 times 4 times 4. That's 6 of them. And then I've got another 6 from this group. 4, 4, 4, 4. And then I've got another 6. 4, 4, 4, 4, 4, 4. Okay, and so I think I got them all there, but I've got 6 from this group, 6 from this group, and 6 from this group. So I have a total of 18. So that would be 4 to the 18th power. Notice the difference. Here, I had both of the bases, and so I add them. I add my exponents. Here, it was a power raised to another power. And in that instance, I multiply my exponents. Now, the great thing about this is, if you are the type that really likes to just, memorize those formulas and exactly how to do it, great. Go for it. You certainly can do that. You can memorize, okay, product of a power, I've got both of the bases, I add them. If you are not the type that wants to remember, or, you just are working one day and you just forget it, you kind of lose it for a half second, it's okay because you know that you can always write it out. Okay, that's the beauty of these. Okay, so let's put some of this into practice. Let's look at this portion right here. Number 1, 2 to the third times 2 to the fourth. I have the same bases. So this would be, if I think about it, this is 2 times 2 times 2, and then 4 of them over here. So I have a total of 7. So this is 2 to the 7th. Notice that that is the same as adding those exponents. Okay? Now, let's look at number 2. Okay? So for number 2, and we're going to talk more about this type when we get into dividing our exponents, but for now, let's think about our general rule. Okay, so this is 8 to the negative second and 8 to the 6th. And I know if it was a negative, I would move it into the denominator. But since I am simplifying here and I'm multiplying, I'm just going to think about that rule. I know if I have both of the bases, what do I do with the exponents? Well, I add them. So negative 2 plus 6 is 4. So this would be 8 to the 4th power. And then the 5 to the 3rd, you don't have anything to combine that with. Okay, so we're just going to leave it as 5 to the 3rd. Now, probably some of you are thinking, well, wait a minute, I could just figure out what 2 to the 7th is. I could multiply 2 times 2 times 2 and figure that out. And you absolutely could, and we will get there. Right now, we're just working with our exponents because we're learning our rules of exponents. So that's why we're leaving this all in the form where we have our exponents. Okay, let's look at the next one on number 3. My same bases I can combine. So I've got 2 to the 4th and 2 to the 8th. So I'd have 4 of them right here and 8 more of them right here. So I have a total of 2 to the 12th. And then as far as my 3s, well, I've got 3 to the 5th and 3 to the negative 2. So I have 5 of them here, but I'm going to take away 2 of them. So I end up with 3 to the 3rd. And that's how I'm going to leave that for now. Okay, now on number 4, we have variables instead of actual numbers, but it's the same concept. My m's are the same bases, so I can simplify those. So I've got 8 m's right here and 7 more right here. So I have a total of 15, so m to the 15th, and then the n, that's the only one of those, so n to the 4th would remain. Okay, now we're getting into power of a power. Power raised to another power. So remember that this is different. This could be expanded as 6 to the 4th times 6 to the 4th. So now, same basis, I've got 4 of them right here and another 4 right here. So I have a total of 6 to the 8th power. And if you think back to where we had our general rules, a power raised to a power, remember that we multiplied those exponents. And so that's where that comes in. Okay. Trying another one of those, 4 to the negative 3 raised to the 2nd power. So power raised to a power, I'm going to multiply these things. So negative 3 times 2 is negative 6. So this would give me 4 to the negative 6th power. But I want to think back to what we just did up here. Remember, we don't want to leave negative exponents. So because this is 4 to the negative 6th power, I'm actually going to move that 4 to the 6th to my denominator, and I have a 1 up top to hold its place. So this would be 1 divided by 4 to the 6th. Okay, trying number 7. I've got 5 to the negative 3rd power raised to the 3rd power. So I multiply these exponents. So this would give me 5 to the negative 9th power. And then I remember that 4 to the 0 power, well, that's just 1. Okay? Now, again, I don't want to leave that negative exponent like that, so I'm going to move that to the denominator. The 1 can stay up top, so I'll have 1 divided by 5 to the 9th. Okay, now let's look at number 8. I've got x to the 2nd power raised to the negative 4th power. Well, that would be x to the negative 8th power. And then I also have the y to the negative 3rd power. 2 negative exponents. I don't want to leave the negative exponents there, so I'm going to move both of them to the denominator. So I'll have x to the positive 8, y to the 3rd, and then because I have nothing left up top, I'm going to put a 1 as a placeholder. Okay, looking at a couple more. Number 9, u to the 5th power raised to the negative 2nd power. So when I multiply those powers, I'll end up with u to the negative 10th. And then v to the third raised to the fourth power would give me v to the 12th power. But I don't want to leave my negative exponent. So I'm going to move that portion to the bottom and make that exponent positive. But the v to the 12th, that can stay up top. It does not need to move. I do not want to move it. It's just going to remain up top as v to the 12th. Okay, now for number 10, I've got negative 3a to the second and divided by 8b. I actually can't do anything else with this problem. There's nothing to combine. There's not a power raised to a power, and so that is going to be it. Okay? Now, I'm going to skip number 11. It's a lot like 13, 14, and 15, and I'm actually going to take a look at those tomorrow while we're in class together, because you can kind of think about those in different ways. So if you want to kind of take a look at those tonight, look at what you've got on the front page that talks about that, and then you can probably form some ideas and get some ideas of what you think we can do there as well, and then we'll talk about that tomorrow when we're all together. But I do want to look real closely at number 12, or real quickly at number 12 before I let you go. So m to the third times m to the 0, okay? So when I think about this, remember that I've got the same bases, so I actually would add the exponents, and 3 plus 0 is 3. So this would be m to the third. Another way you might think about this is, remember that anything to the 0 power is 1. So this is the same as m to the third times 1. Well, anything times 1 is just that thing, right? So m to the third times 1 would still be m to the third. So you could think about that either way, and you would still get the same answer. All right, I will see y'all tomorrow, and we'll chat some more about exponents.